So this is for today lecture, starting from the distance traveled by the particle in the fixed length of L, starting from 0 to L. That means the distance between two ends is x, as we have already explained in the previous lecture. So I am starting with the same equation, that is the momentum rho, and the momentum is the mass into velocity. And whenever you explain in the quiz, you must have to explain what are these m and v, because you are just writing the alphabets. Alphabets are not important. You must have to describe what is m and what is p. That's why I have detected some of the marks based on your insufficient explanation. And when you explain everything, that means you will get the 100% marks. And some of you have already got the 100% marks in this course. Okay? Now, what is the velocity? Actually, this is the distance traveled. So have a just look, what is the velocity? Velocity is actually the vector measurement of rate and the direction, or simply you can say velocity is the speed at which something moves in one direction. So what the difference between the speed and velocity is just the direction. If the direction is not given or not known, then it is speed. And when you say it is moving from this x-axis, y-axis, that means you are indicating the direction, and then this speed will be called the velocity. And velocity actually, and or the speed is the rate, and the rate is the change in position with respect to change in time. So change in any property with respect to time, actually this is called the rate. So like you say, rate of the reaction. So how can we express the rate of reaction? Actually, this is the same way we can express the rate of the reaction. And in the reaction, the concentration are going to change, and we say change in concentration per unit time. And here, the speed is going to change with specific reference to the direction, and this speed is called the dx over dt. X is the distance traveled, or the change in the distance from one position to another position. Like I am starting with the 0 position, and I traveled, let's suppose, 1 kilometer. So what would be the distance traveled? It is 1 kilometer. And how much time I am going to take this one? Maybe it is 1 hour. So 1 kilometer per hour, that is called the rate simply. So this velocity is the change in the position or the distance travel with respect to change in time. And it is written over here, distance travel per time. This is called the velocity. And the direction is not given because this is the vector measurement. If there is the indication in the direction it is moving from one direction, then of course it will be the velocity. So what I am going to do, this one, now velocity is the second equation is I am just putting the value of v in the momentum. Momentum is the mass into velocity, and the velocity here I have mentioned over here, it is dx over dt. So put the value dx over dt in this equation, and now this is the another equation of the momentum. This is the mass into, this is the same, it is the velocity, but velocity is the rate, and this rate is the distance traveled per time. That is the same thing. That means the first one, this equation and this equation, there is no difference. Just this is more elaborated as compared to this one. Clear? Now, if you want, because I am tested over this one, distance travel, and distance travel is the dx over dt, and just this is a rearrangement. Here it is multiplying, and when you are moving to the left side, it will be divided by the rho, and the equation will become rho divided by m, and this is the momentum, this is the mass, and this is the distance travel per time, that is the velocity. Yahi target hamara hai, theek hai? Now next, as we have previously derived this equation, do you remember? In the previous lecture, we derived this equation. The rho will be equal to 2m e under root. And I'm going to show you. This is the equation. We ended the previous lecture over here. You can watch again the video. How can we derive this equation? Actually, this was the momentum, and this was the kinetic energy, and this is the energy, and we are actually using this energy or the momentum to put the value in the this equation. So this is the equation I have mentioned over here. So in the last lecture we have already derived this one. So I'm moving to the again. This is the same momentum we derived before. So why I have put it over here. Now the next step is to put the value of the momentum in the above equation. ये आपके पास equation है. Now I am just replacing this row with this value. So this will become 2me under root over m. Is there any confusion? Very simple. So now I am going to again rearrange this equation. Now actually this is the final equation, but next I am going to just, it is the rearrangement. Why I am doing this one? Because here if you have a look in this equation, the last one, m is here, m is the mass of the electron, and this is also m. So in one equation there should be a one time displacement of any of the values. So one mass mean if it may be in the denominator or it may be in the numerator. So there should not be the single symbol or the value two times in our equation. So I'm just rearranging. How I'm going to rearrange? I'm just by using this one, like let's suppose m will be equal to m square under root, and this is the same thing. If you this multiply divide this, and this will become m. So this and this, these are equal to each other. There is no difference. So why I'm using this one? Because here I'm going to replace one of them to have the value of only one time in this equation. So let's see. Now I'm putting this equal to m, and this is the m, and m is equal to this one. I am just replacing here m square under root. Now it is in one equation. So now I'm you can easily cancel out one. This one is cancelled out by 1m. So what is the next? This is the final equation. Now m is 2e over m under root, or this is more clearly you can represent by using this equation. So here this is just the rearrangement of this equation, and finally you can get the value of this. And this is the distance traveled per time. You can calculate the distance traveled by the electron in a time by using this equation. And what is this? 2 is the constant, E is the kinetic energy. As we have, if the kinetic energy is given, just unknown is the kinetic energy, mass is of the electron is the constant, 2 is the constant. You can solve this one, take the under root, and this will give you the velocity of the electron. And this is very important, you think. First you calculated the kinetic energy of the electron, and now we have, you can also calculate the velocity of the electron, or in terms the position of the electron. Velocity यही बताएगी ना कि आपके पास कितना डिस्टेंस इसने ट्रेवल किया. That means इस वक्त इलेक्ट्रॉन कहाँ पे होगा, किस डिस्टेंस के ऊपर होगा. And this is very important because these subatomic particles are invisible, but you can know predicting what is the kinetic energy, what is the position of the electron, how much distance they have traveled in a box or in a shell. Okay? And but remember, according to the Heisenberg uncertainty principle, because this is a position and there should be uncertainty in the position and the momentum, and the value is h over 4 pi. So if you just let me finish. So if there is this delta x is the again the position, and this is also giving you the position. So if you want to accurately measure the position, there should be a more uncertainty in the momentum. And if you measure more accurately, you want to measure more accurately the momentum, then there should be more uncertainty in the position of the electrons. And this value at least is, this is the value h over 4 pi, and it may be more than this value. It depends how accurately you want to measure one parameter, and then uncertainty will go to the rest of the parameter. And this is the all about the distance travel. So I'm just closing this video, starting with the new one, because this is the one topic we have discussed over here.